This program demonstrates the theory behind interference, that is principle of superposition, and to have some idea of coherence. So in this program you can see there are two charts. The top chart shows two individual waves, sine waves, having an amplitude 1 and same frequency. Okay, both waves are having same frequency. And the bottom chart shows the superposed wave. That is, according to the superposition principle, if two waves are entered simultaneously in a medium, so the resultant uh, amplitude of vibration, okay, the resultant displacement at a position is equal to the sum of individual displacement by the individual waves. That is superposition principle. Okay. So in this program, I am also doing the same thing. I have two waves. I am simply adding the displacement at every point. So I can introduce any phase difference between these two waves, any phase difference between 0 and 180 degree, that is 0 and pi radian. Okay, I can vary the phase difference here. And let us see, so these two waves having a slight phase difference. Right now the phase difference is 39 degrees. Okay, and you can see that the superposed wave is having an amplitude greater than 1 and slightly less than 2. Okay, again say I can set a phase difference of maybe 45 degree. So these two waves are having a phase difference of 45 degree, and the resultant amplitude is slightly less than 2, but that's fixed. That amplitude is not varying, that is fixed. Okay. Now maybe I can introduce another phase difference, maybe 90 degree. Okay, so these two waves are having a phase difference of 90 degree, and the resultant superposed wave is shown here. Okay, that is simply the algebraic sum of these two waves, and you can see that the resultant amplitude will be root 2 times the individual amplitude. Individual amplitude is 1, so that will be root 2 times 1, so that is really approximately 1.415, like that. Okay, and see what will happen if I again increase the phase difference. Again I am increasing the phase difference. You can see that the amplitude is decreasing. Okay, now the amplitude is less than 1, but a fixed amplitude. The amplitude is not varying. Okay, again I increase the phase difference to 180 degree. What will happen? If I introduce a phase difference of 180 degree, these two waves are having exactly out of phase. Okay, 180 degree phase difference. So the superposed wave will be, amplitude will be 0. Okay, because for example, say sine 90 degree. Sine 90 degree is 1. Sine 270 is, that is minus 1. So if you add both, you will get 0. So at every point, you will get the resultant vibration 0. So the resultant amplitude will be 0. Okay. So this is the principle of superposition. Okay. So I'm setting some say 0 phase difference. I'm introducing 0 phase difference. So basically there are actually on the top chart there are two waves. You are not able to distinguish the two waves because both are oscillating in same phase. So okay, one overlaps on the other. So you won't see any other two waves, individual two waves. Basically there are two waves. And the resultant amplitude of the superposed wave, you can see that that is 2. Amplitude is 2 because individual wave is having amplitude 1. So resultant wave will be having an amplitude of 2. Okay, but a constant amplitude. Amplitude is not varying. So that is basically principle of superposition. Okay, so I just put some arbitrary phase difference. Okay, or I will introduce 0 phase difference. Right, let it be there. Now you're getting a fixed pattern, fixed superposition wave because the amplitude is not changing. Now this happens because two individual waves are having same frequency. Now what will happen if the frequency changes? Okay. So if the frequency of the two waves does not match, so what will happen? So I can introduce a frequency difference, say 5% frequency difference. I set a 5% frequency difference. Okay. Now you can observe the superposed wave. Okay. Superposed wave will not have same amplitude. The amplitude keep on changing. Now it is maximum. After some time we can see that the amplitude becomes 0. Okay. Now the amplitude is decreasing. Okay. You can observe that the amplitude is decreasing, and finally it will end up 0, and again it will increase in amplitude. Now it is 0. Now amplitude increases and it becomes maximum. Okay. So in such a case, the amplitude varies. Okay. So you won't get a fixed interference pattern. Okay. Interference pattern keep on changing. So you won't observe any interference at all. Okay. So to get a prominent interference pattern, the two individual waves should have same frequency. That is first condition. Okay. Otherwise, these two you won't get any interference. So for a for coherence, the both individual waves should have same frequency.